Every single second the universe gets bigger. Not just a little bigger either, the part of reality we can see expands by thousands of kilometers every moment, but here's the terrifying part. That's only the piece we can see. We live inside a bubble of observation, a sphere of light that's had enough time to reach us since the beginning of everything. We've measured this bubble, we've even put a number on it. But what if that number, as mind-shatteringly huge as it is, describes nothing more than our own cosmic backyard? What if our entire reality is just one grain of sand on a truly infinite beach? The question, how big is the universe, seems simple, right? We've all heard an answer before. It's a sphere, with us smack dab in the center, about 93 billion light years across. That number is the absolute limit of our vision, the edge of what we call the observable universe. For all practical purposes, that's the size of our reality. But that answer, as concrete as it sounds, is also deeply misleading. It's like measuring your house and declaring you figured out the size of the Earth. To really get a feel for the scale of it all, we have to go on a journey that starts right here, on our familiar blue marble, and zooms out past stars, past galaxies, all the way to the very edge of what we know. But we're not stopping there. We're going to push past that horizon and confront a concept that pretty much breaks all the rules and changes everything we thought we knew about our place in the cosmos. This is the story of not one but two universes, the one we can see and the one that might just stretch on forever. Our journey starts at home, Earth. It feels huge to us, a world of massive oceans and sprawling continents. But in the grand scheme of things, it's a speck. To give you some perspective, if the Earth were a single grain of sand, the Sun would be the size of a basketball. Our planet is just a tiny, fragile fleck of dust orbiting a very average star. The distances, even in our own neighborhood, are just staggering. The moon is our closest celestial buddy, but it's so far away that you could fit all the other planets in our solar system in the space between us. When the Apollo astronauts made that trip, it was called humanity's greatest journey, but on a cosmic scale, it was like taking a single step out your front door. To go any further, we need a new ruler, because kilometers just don't cut it anymore. We need the light year. Now, a light year isn't a measure of time, it's distance. It's how far a beam of light, the fastest thing in the universe, travels in 1 year. That's about 9.5 trillion kilometers. Think about that. Light can zip around the Earth 7.5 times in a single second. Yet it takes more than 8 minutes for light from our own sun to reach us. The sunlight warming your face right now is 8 minutes old. We are, in a very real sense, always looking into the past. Let's keep zooming out. Our solar system, with all its planets and asteroids, is just one tiny piece of a much bigger structure, the Milky Way galaxy. Our home galaxy is this enormous, swirling city of stars. If our entire solar system all the way out to Neptune were the size of a quarter, the Milky Way would be the size of North America. It holds somewhere between 100 and 400 billion stars, and probably just as many planets. Our sun is just one of them, tucked away in a quiet spiral arm about 2/3 of the way from the galactic center. The galaxy is so big that even at the speed of light, it would take you 100,000 years just to cross it. Every star you can see in the night sky with your own eyes is in our galaxy. There are neighbors in this giant city of light. But our city isn't alone. The Milky Way is part of a small galactic neighborhood we call the Local Group, which includes our biggest neighbor, the Andromeda Galaxy, and yes, Andromeda is currently on a collision course with us, set to arrive in about 4 to 5 billion years. And the Local Group? It's just one of many. Now we pull the camera back even further, and we start to see that galaxies aren't just sprinkled through space like random dust bunnies. They're organized. They're connected. Bound together by gravity, they form a vast, intricate structure that looks almost like a web or the neurons in a brain. This is the cosmic web. This web is made of massive filaments of galaxies and dark matter stretching for hundreds of millions of light years. These filaments connect at dense hubs called superclusters, which are the largest known structures in the universe. Our Milky Way is just one of about 100,000 galaxies in the Laniakea supercluster, a colossal structure that spans over 500 million light years. And in between all these glowing filaments are the great cosmic voids, immense regions of shocking, profound emptiness, some over 1 billion light years across. From this viewpoint, entire galaxies are just pinpricks of light. Our own Milky Way is completely invisible, lost in a sea of countless others. This incredible web-like pattern is the large-scale structure of our universe. And now, we're ready to zoom all the way out to the absolute limit of what we can see. We've finally reached the boundary of our knowledge. This is the observable universe. From our spot on Earth, we can look in any direction and see light that has been traveling for billions of years. The absolute oldest light we can possibly see is the cosmic microwave background radiation, the faint leftover glow from the Big Bang itself. This light has been traveling for 13.8 billion years, the entire age of the universe. So, does that mean the universe is a sphere with a radius of 13.8 billion light years? Nope. And the reason why is one of the most mind-bending ideas in all of science, the expansion of space. See, the universe isn't some static box that galaxies are just flying through. The very fabric of space itself is stretching. Since the Big Bang, space has been expanding everywhere, carrying galaxies along for the ride. This means that a galaxy that shot out some light 13.8 billion years ago was much closer to us back then. But in the enormous amount of time it took for its light to finally reach our telescopes, the expansion of space has carried that galaxy much, much farther away. When you do the math, it turns out that the galaxy whose ancient light is just reaching us now is currently about 46.5 billion light years away. Since that's true in every direction we look, the observable universe is a sphere with a diameter of about 93 billion light years. This is it, the edge of everything we can ever hope to see, touch, or interact with. A bubble of reality, 93 billion light years wide. It's a number so big it's basically meaningless to our brains. But this brings us to the most important question of all. Is this bubble the entire universe? The answer, according to our best science, is almost certainly no. Our 93 billion light-year bubble is not the whole show, it's just our observable part. Any other spot in the universe has its own observable bubble centered on itself. An alien in a galaxy 60 billion light-years away from us would see its own 93 billion light-year sphere with some parts we can see and huge chunks that are forever beyond our horizon. So how big is the whole thing? We don't know for sure, but we have some pretty strong clues. Probes that have measured the cosmic microwave background have analyzed the geometry of the universe with incredible precision, and they found that, on the larger scales, the universe appears to be almost perfectly flat. Think of it like this. If you're standing in a small field, the ground looks flat. You can't sense the massive curve of the Earth. But we all know the Earth is a sphere. The universe looks flat to us because it's likely that our entire observable bubble is just a tiny, tiny patch of a much, much larger structure. In fact, based on just how flat the universe appears, some cosmologists calculate that the entire universe must be at least 250 times larger than the observable universe. That's a diameter of nearly 7 trillion light-years. And some theories suggest it's vastly larger still, maybe even infinite. Let's just stop and think about what infinite really means. If the universe truly goes on forever, then anything that can happen will happen. Not just once, but an infinite number of times. If space is infinite, and the stuff in it is arranged more or less randomly, then, somewhere out there, far beyond what we can see, there's another Earth identical to ours in every way. Except on that one, you picked a different shirt this morning. Go even farther, and there's a version of you who became an astronaut, and is out there exploring those distant galaxies. Go farther still, and there are exact physical copies of you living your exact same life, down to the last atom. In an infinite universe, every possible choice, every outcome, every weird configuration of particles exists somewhere. There would be planets made entirely of diamond, alien civilizations that have mastered galactic travel, and cosmic structures so bizarre we can't even begin to imagine them. This isn't just sci-fi speculation. It's the statistical, logical outcome of a universe that has no edge. It means we live in a cosmos that isn't just bigger than we imagine, but bigger than we can imagine. A place where being unique might just mean locally rare. So we started with a simple question. How big is the universe? We went from our little blue dot to the vast cosmic web and finally to the edge of our own reality, a bubble 93 billion light-years wide. But we found that this wasn't an edge at all, it was just a horizon, a limit not of the universe but of our own vision. Beyond that horizon lies the great unknown, a universe so vast it might as well be infinite. Our entire existence, all of human history, every star and galaxy we can see, could just be one tiny, finite neighborhood in an endless expanse. So the next time you look up at the night sky and see all those stars scattered across the darkness, remember what you're really looking at. You're not just looking out into empty space, you're staring into a mirror of infinite possibilities. You are a part of a cosmos that may repeat in endless variations forever, and our place in it all is both unimaginably small and, because we have the ability to wonder about it, immeasurably profound. If this journey to the edge of reality and beyond just expanded your mind, do us a favor and hit that like button. What's the one idea about the universe's scale that's going to keep you up tonight? Let us know in the comments. And for more deep dives into the biggest questions in science, make sure to subscribe and ring that notification bell so you never miss an adventure. Thanks for watching.